Hello and welcome back to the channel. In today's video, I'm going to show you how to use Python to act as a TCP IP server or client. So I'm going to go through this code with you line by line and talk a little bit about TCP IP protocol along the way. Basically, an internet protocol for messaging between devices where there's a client-server relationship. So the server is really the active component and the client is kind of the passive component. That's an oversimplification, but hopefully that's enough of an explanation that we can start talking about this project. This sort of concept definitely sort of straddles between the realm of like the IT world and the programmer world, and in my case, like an automation engineer world. But we're going to go through line by line. We're going to start by taking a look at how to set up a TCP IP server script in Python, and then we'll take a look at how to set up a TCP IP client script, and then we'll actually look at how running those two at the same time can connect even on one machine. Okay, so let's get started by creating a simple TCP IP server. All right. And so the module, really the only module we need to do this sort of thing in Python is called socket. So we want to import the socket, and then we actually want to create a TCP IP socket. So we imported the module called socket that has the functionality to allow us to create a TCP IP socket, but we haven't done anything with it yet. And so what we'll do is we will say sock equals socket the module, and then dot socket the command within the socket module, and then these two parameters in here, socket.afinet and then socket.sockstream. This is where I'm going to be perfectly honest, I'm not a network expert. These are the parameters I've always used to get this working, and so these are the parameters I always put in here, and it's worked thus far. I promise if you want to dig a level deeper into the socket modules documentation, you can get a better explanation of what each of those are doing. But then we want to bind the socket to the specific port for the server. Okay, so the way port for the server. The way TCP IP connections work is the server has an IP address and a port that both the client and the server need to know about, and then the client is kind of choosing any open port on its side when it connects, if that makes sense. So the port only has to be hard coded for the client and the server to listen to as it relates to the server. Let's keep programming. I think it'll make more sense when you see it written out. But so we'll go ahead and we'll say that the server address is equal to, and in this case, I want it to run right on this machine. So I'm going to say localhost. You could also throw the IP address of your computer in here instead of localhost. So my computer is like 192.168.1.64 or something right now. I could put that there. Instead, I'm going to say localhost, and then I'm going to just throw port 10,000 on there. I'm also going to spell address correctly. There are something like 62,000 ports that you can use. So just pick a memorable one. I'm going to use 10,000. And then let's print a command, something that is very smart to do when you're dealing with like networking and stuff that could kind of go wrong at any moment, is give yourself a lot of print statements. And so what we'll say is we're starting up and then we'll use two variables in this, and then we'll say what connection the server address has. So this will tell us the host IP address and the port that we're using. And this sort of format for passing in variables into a formatted string is a little bit different than I honestly typically use. I usually use formatted strings and then curly brackets, but I'm not gonna lie, there's some really good Stack Overflow code that I was able to use as the source of a lot of this, and they did their prints this way, so I'm doing them this way. So all we've done thus far really is we've bound the server address, which is the IP address or the host, and then the port, and we've bound it to the socket instance that we created. Then we need to listen for inbound connections, and then we want to just use sock.listen, and then 1. You could do 5. You could mess with the variables in there. Sock.listen1 is good enough for rock and roll. So then what we want to do is we want to wait for a connection, and we just want to keep listening, really. So the server does pass data outbound, but it's also just while true. We want to wait for a connection, because there's not necessarily a guarantee when you have a server that there will be any clients pulling from it. So we want to basically just wait for a connection to come in. All right, but then what we'll do is we'll say print waiting for connection, and then we will say connection and the client address are the two things that we're going to pull back down from sock.accept. So another command within the socket module is sock.accept, which is basically us saying, okay, when something hits our server, we're going to accept it, and we're going to keep track of who's connected to us in this connection and client address variable. Then what we'll try is we will print connection from, and then we will say the client address. So this will be a little print statement telling us who's connected to us. And as you'll see when we set up the client piece in the second half of this tutorial, you'll see exactly where that comes from and what it looks like. So what we want to do is we want to receive, man, that's a tricky one to spell, receive the data in chunks of bytes. And so to do that, what we want to say is while true again. So now we have tried to connect, and if we've got a client address, then what we're going to do is we're going to say, okay, the data is equal to whatever we're receiving, connection.receive from that port. And this is where you define how many bytes, the buffer size, you want to pull in one message. I've seen this be like 16 bytes. I've seen it be quite a bit larger. So this is supposed to be specific-ish to the size of the messaging that you'll be receiving. But in any case, you can make it a really large value, because at worst case, you'll receive everything that's in there. So then we'll say we've received, and then %s here. And then what we'll do is we'll pass in all of the data that we received. Okay, so we've got this going on. And now what we're going to do is we're going to say if there's data. So if in fact we have received anything over that connection, then what I want to do is I want to send it back to the client. So that way we can show the data to and from TCP IP using like an echo listener client server relationship. So sending data back to client. And what we're going to have at this point is a bytes object. So it's going to look like a string if you were to just print it out, which we do up here. It's going to look like a string, but it's technically bytes. And so what we want to do, if we want to be able to manipulate it like a string, we want to do string of data, and then we can start adding stuff to the message. So let's say that I want to send it back as whatever the original message was, and then I want to say plus extra from the server. So in the world of programming, if all the client was sending to the server was hello world, then this might be hello world plus extra from the server, and then going back to bytes format, because that is how we send messages over TCP IP. So I know we're moving kind of fast, but if you have any questions about the specifics that you see during this tutorial, let me know in the comments below, because there is a lot to cover and I don't want it to be like a crazy long tutorial. So what we're doing here is we are taking all of the data that we get from the client. We are adding a little bit of text to indicate that the server did read it and is sending it back. Then we're converting it back to bytes using this encoding protocol called UTF-8. It's a method of encoding strings into bytes. And then we send it back over the same connection. Now, because we had an if, we want an else. And if we don't get any data, we want to print no more data from, and then the client address. So this is just a way of saying, hey, we're pretty sure we've read everything that was available there. So we'll do connection.close to clean this code up, and then we'll do a break. And that should escape our while loop. And then because we have a try up top, we can throw a finally down here, and we'll just say clean up the connection. And I'm sorry, I think I misspoke earlier, connection.close. This is where we want connection.close in our finally code. We do not need it here. Although strictly speaking, I don't think it would hurt anything there. And all of the code that you're seeing here for both the server and the client will be in a GitHub, linked in the description of this video as well. So if you'd like to not have to follow along line by line, it will all be linked below as well. So you can go and grab it directly. But what we have done here to SparkNotes speedrun through it, we imported the socket module, we created an instance of a socket, stored it in this variable sock, we defined our server address, which for our application will be this machine and port 10,000, and then we bind the server address to our socket item, and then we are listening for inbound connections. When we get a connection, we store it in this connection, comma, client addresses, those two variables. We display who's connected to us, and then we start receiving data. And when we receive data over the port through TCP IP, if we get data, we add a little bit of text onto it to basically say, hey, we got this, and then pass it back to the client by encoding it as bytes. And then when there's no more data to be processed, we close it, but it will return to the outer while loop, which will continue waiting for a connection, because the nature of a server is you don't necessarily want it to close every time you close a connection with a client, if that makes sense. So you want the server to keep running even as clients pop onto the network and pop off of the network. So let's go ahead and table this right now, because if we were to run it right now, all you're going to get is, okay, we're starting up the local host and now we're waiting for a connection. Because we haven't created the client yet and I don't have a machine that is a TCP IP client hooked up to my laptop, we're not going to hear anything over that connection yet. So let's put a pin on this, the server side, and let's write the client side together, and then we'll run both of them and we'll talk about what we've built once they're both written. All right, so now let's go ahead and create a TCP IP socket for a client. All right, and the beginning is going to look very quick, very similar, so I'm going to go pretty quick, where sock is still equal to socket, the module, dot socket, and then still socket dot af inet and socket dot sock stream. There we go. And then what we want to do is we want to connect the socket to the port where the server is listening. Okay, so the line is going to look exactly the same. Server address equals localhost and then port 10,000. The reason for this is, like we talked about a little bit earlier, the client only needs to know the IP address and the port that it needs to use on the server. The client, assuming your TCP IP server does not have like a bunch of security or firewall rules on it, the server is the one that has a hard programmed port number and IP address, and it's going to receive data from clients, and it's kind of like a surprise what the IP address and the port of the client that are getting used are. So the server is the one you have to define both on the server side and the client side. So what we'll do on this side, rather than saying starting up a server, we'll say that we are connecting to, and then very similar to the command, we'll say we're connecting to this address and this port, and then we will just pass in the server address parameters. Okay, so that'll still give us some useful information in the console window. And then we'll do socket.connect to the server address. Okay, and what we'll do now is we will try to send data to the server. All right, so we want to try to send data, and we'll say, in this case, it'll be a message, and it'll just say, this is the message, and then we will say, please repeat. So we're basically asking the server to read our message and send it back to us. And then, just so that the print command knows, we will say that we are trying to send, and then a variable, and then we will say we are trying to send this message. And maybe to show that it's a quote, we'll do that. Print send message. I think I missed a space. There we go. All right, and moving on, we'll say sock.send all. Okay, so send everything that is in that message. But if you remember, because that is a string, we need to encode our message in UTF-8 format and turn it into bytes. So we can do this just like putting str before a variable makes sure it's a string, putting bytes before a variable, and then an encoding protocol makes sure that it is a bytes object. Okay, so now we will look for a response back. Okay, and we'll say the amount that we have received starts out as 0, and the amount that we expected is going to be at least the length of the message. Okay, so we don't necessarily know on the client side if the server is going to be sending anything back or not, and these ones are kind of specific for the application I'm setting up here, which is an echo client, basically saying I'm going to send data, I would like you to send the data back, more or less, just to establish the connection. But what we'll say is, while the amount that we've received is less than the amount that we expected, that means that we want to keep listening. So data equals sock.receive, and we'll say 1600, right? Because that was kind of the max that we said we were going to receive on the server side. And then what we'll say is, okay, the amount received just went up by the length of the data that we sent. So this is just a tracker, more or less keeping track of how much inbound data have we received. And we'll print out everything that we've received to show that we got it back on the client side. And then data. And then we will add, just like in the server side, we had a try and a finally. We will say in our finally that we are going to print closing socket. Okay, so to give an example of the client whose mission is basically connect to the server to do a specific task or pass a specific piece of data, and then when the work is done, it's okay to do sock.close, because you're basically saying, hey, the socket that I was just using, until I need to connect to the server again, I don't need that connection anymore, so I'm just going to go ahead and close it. The server's job is to be open and constantly kind of listening for connections on that port, and the client's job is basically to connect when it needs to connect and send data when it needs to send data. Okay, so I know there was a lot in this. Again, I know industrial networking, and not even industrial networking, really, this is just like networking in general. I know this is a little bit different than just straight programming, but this is a really important concept, especially as you get into communication protocols. So let's go ahead and run some tests here. I think I can get kind of a crafty view here where we can see our server on the left. Nope, that's also the client. Here we go. We can see our server on the left, and we can see our client on the right. And I'm going to make the text a little bit smaller. I know if you're watching on like a phone, this is probably a lot harder to read, but it was big while we were programming. So that's half a win. So here's the order we're going to do things in. We're going to kick on our server right now, and in the window, you can see we get, all right, I've started up on this local host on this port, and I'm waiting for a connection. Now, if we did this right, when I run the client over here, run client, So you can see some action in the terminal window of the server. It was waiting for a connection. Oh, I got a connection from, and then this 127.0.0.1 is really the loopback IP, meaning same device. But here you can see, like, this is the IP address and some random port that the client chose to connect to the server. And so we say, hey, we got this message. This is the message. Please repeat. So we decide to send data back to the client. Then we get an empty message. There was no more message, so the socket closed, and now we're waiting for a connection again. That's what happened on the server side. Usually you would use the data that you received to do more than just kick it back to the client as an echo. That's where you would do something useful with the data. But for the sake of explaining how to use a TCP server, I think we've covered it. Let's take a look at what the client was doing. We were connecting to, and it could see localhost on port 10,000. Then once we were connected, we sent, this is the message, please repeat. And then what we got back, and you can see these B's in the beginning because we formatted it as bytes. So if you wanted to get rid of that, all you have to do is a little bit of like string data cleanup. But what we got back was, this is the message, please repeat, plus extra from the server. So you can see the client sent a message over there and then received back the message as an echo plus the extra message from the server. And then we closed the client. So what's really cool, I have not restarted the server, but the client program stopped. The script stopped because it sent the message over that it wanted to send. So what we can say now is, new message, please repeat also. And I have not touched the server script. It's stayed running the whole time. But if I run the client again now, you can see the server just said, oh, it was waiting for a connection. It got a new connection, and what you can see here is a symptom of how clients work. It used a different port this time because the client is just going to grab an open port. And then it said, oh, hey, I received new message, please repeat also. I'm going to send it back. And then I had no more data, and then the connection closed, and now I'm waiting for a new connection. And what happened on the client was, I'm sending new message, please repeat also, and then I received back new message, please repeat also, plus extra from the server. Okay, so I know that this covered a lot of material, and I know that I kept it moving pretty quick. Again, the code will be linked in the GitHub below, and I will get back to you on any questions that you have as soon as I can. So be sure to drop those in the comments below. I thought this was a super interesting concept. It came up in my work recently, and so I was working on some bigger like Arduino tutorials and physical builds, and I was like, you know what, that was super useful for me, and I had a little bit of a hard time finding useful resources on the internet. So once I figured it out, I figured it'd be good subject matter for a video. I hope you guys enjoyed it. Be sure to let me know in the comments below what you'd like to see more of on the channel. Thank you to everyone for continuing to support Lemaster Tech. A massive thank you as always to my Patreon supporters. Good luck with your projects. Thanks for watching, and until next time, bye.